Hello and welcome to part 4 of our module on the Industry 4050 Robotic Tele-Operation for the Future Internet of Skills. This is our final module and it will wrap up some of the concepts and ideas that have been presented in the first 3 modules. One point which I thought was quite relevant is to link in the Internet of Skills and what we've been discussing in the various modules in relation to the United Nations Strategic Development Goals. At our university, University College Cork, we are required to justify all forms of our research in relation to the SDGs, which we call the Strategic Development Goals. This work was presented some time back, about 18 months ago, at a conference in UCC on the Strategic Development Goals. And the Internet of Skills, and underneath that, the work we're doing as part of the IMOCO project under use case 3. We believe that our work links to, there are a whole number of strategic development goals, and we've particularly picked out that we relate to Goal 8, which has to do with decent work and economic growth. Also, clearly, we're in the whole area of strategic Goal 9, which is industry, innovation and infrastructure. And then there's the more, I suppose, global perspective in terms of global partnerships and how these partnerships will bring about change for good on a global scale. And going back to goal number 8, clearly we're looking at Internet of Skills, new working potentials, the re-engineering of jobs, productive employment, safe employment, eliminating slavery. All of these aspects are indirectly tied into the work we're doing and strategic goal 8 of the SDGs. The scientific one, there's no question, we're involved in industrial 4.0 and 5.0. It's all innovation, it's scientific research, etc. So clearly we fit into the SDG goal 9 on industry, innovation and infrastructure. And as this work develops, as the Internet of Skills, I've already mentioned that the potential here is to transform jobs and transform our connectivity and the capabilities of what we do when we're connected across the internet, way beyond the typical data, knowledge and the type of generative AI that has been done using the internet infrastructure at the moment. So clearly that will lead to all forms of global partnerships. The technology is the enabler of the transformation of society on a global scale. So that would be our vision, and that's our justification for our involvement in the United Nations Strategic Development Goals. So in our own little way, under our research project, IMOCO and use case 3, we believe there is a contribution on a global scale. Now, I've just picked up the graphic that you've seen already, and I've given you the specific reference for that graphic. So there's quite a good paper there from Doller et al. And that's the Internet of Skills where robotics meet AI, 5G and the tactile internet. So clearly, just to remind you that the complexities of what is currently being built and will be enabled in the future, but there are so many different elements, fast networks, all forms of sensors, encoders and tactile and haptic type of communication sensors, and critically what AI is going to bring to this infrastructure in the future, which is our intelligent Internet of Skills. But there are major challenges. I'm just going to outline them briefly here because each one of these is a research project in its own right, and particularly our interest is looking at latency. We look at latency in the sensors. We look at how can AI on the edge improve the latency in robotic teleoperation. And we look at the direct telecommunications latency aspects of our research as well. So this is where the major challenge is. How can you realistically communicate thousands of kilometers in real time, such that what is done at one end is 100% accurately reflected in real time at the other end of a platform. So latency is a major challenge. Very topical today is the safety, because when we start moving these robotic systems out of being constrained, and also the control and what level of autonomy is enabled by AI systems can equally have an impact on human safety. So this is very, very topical. As we all know, there doesn't, currently this has been produced in November 2023, and there isn't a week goes by when there isn't some aspect of artificial intelligence discussed in the media. So we now have to take this whole aspect of the impacts of these future technologies and how we involve and address the human safety aspects in the whole infrastructure. The advancements of sensors, particularly with the Internet of Things and the enablement of sensors to address all forms of human sensing, on a more conservative aspect, the powering of all these Internet of Things devices and the Internet of Robotic Things is all going to have a major requirement in terms of the minimization of power and battery utilization. So there's research that has to go on there. And also the sensors we haven't thought about yet. How deep do we go into the human brain? Do we actually start to get into that frontier? Now there are dedicated companies like Elon Musk's Neuralink, Facebook, or Meta, I should be saying, are doing quite a lot of research in this whole human brain interfacing. So that's an area that is definitely going to see considerable advancements and growth over the coming years. But we've thought about that, but it's the sensors that we haven't really considered yet. So that's one of the challenges and the opportunities that I also see is very, very important. The human-machine robot interfacing, I think I've addressed this throughout the various parts of this education module. This, again, it's a field that has been around for a long time, but my core feeling is that we haven't even started. We haven't really even got to the starting line in terms of the complexities of humans truly interfacing with robots on a grand scale, on a global scale. So I certainly believe that this is going to be a major challenge. It is the future, and those of you in research will know that we are now seeing dedicated conferences to this whole area of collaborative robotics, and I've already talked and referenced swarm robotics, etc. So this is really going to be a critical specialized field of research and advancement in relation to the Internet of Skills. I think I could build on that because there is so much hype around artificial intelligence, machine learning, the black box AI modules, etc. We'll see a lot of this start to move towards maturity as the laws are put in place across various continents, and governments are trying to deal with this evolving field of artificial intelligence. So, and I personally believe that there's a lot of marketing and sales hype around where AI is today. But all of that will settle down and we'll start to do the real work. And the real work for us is how can we use AI to address the latency in robotic teleoperation problems? Can the AI predict ahead of time exactly what a user is going to do in a loosely predetermined task? So we are a long way off from being able to use AI in those type of everyday real world problems. So it is still, AI is really very, very early days, and there's a lot of work and a lot of research and major challenges that we're going to encounter in the future. I mentioned digital twins, and I referred to this in the previous modules, and this equally, there's again a lot of interest in the digital twins, but think about the digital twin is not just a 3D representation of something from the real world. It needs to have the physics, not only the geometry, but the real embedded physics. So think about it of a digital twin of a car engine. So the physics is that the water in the radiator, every time you drive the car, a certain fraction of that is going to evaporate. The oil in the engine is going to be transforming as you're actually using the actual engine itself, and the heat of the engine. So how can all those physics, the physical aspects of a real world object be represented into a digital twin? So similarly, these are future challenges and where major advancements will have to exist. We believe digital twins will complement robotic teleoperations significantly and will have a major role to play, particularly when you come in relation to improving the AI aspects of robotic teleoperation interactions. I've left this one because there's ones we haven't even thought about. And as the research advances directly in the Internet of Skills, new challenges will certainly arise. Really move to closing off this module. I've pulled in some references which will help you with additional reading, and I identified some points from these various references. So this is 5G case study of Internet of Skills. It's called Slicing the Human Senses. So it does very much relate to what we presented here, and it'll give you a lot of background reading. And of course, that paper will have additional references if you want to read a lot more. And a few points I picked up from this particular paper is, we're talking about cognitive robotic capabilities. And if all of these objects, Internet of Things, Internet of Robotic Things, etc., and whatever other type of Internet we're going to have, when all of that is dynamically connected, we've got an extremely sophisticated, technologically enabled ecosystem. So what that's going to do and enable, we're putting a certain amount of that in under a category of Internet of Skills, but of course in the future it could evolve into something completely different. In terms of robot skills, these really could enable that services are consumed through the internet, which are continuously evolving by the collected experience of millions of robots. So I thought that jumped out at me. So you could potentially have robots learning from each other, humans learning from robots, as robots perfect a means and a mechanism of carrying out a particular task. So you have the whole concept of this whole collective of robotics, which we started off at the very early stages of this module. All of this is enabled by what we've already mentioned, the advances in telecommunications, advances in AI systems and computing, and the whole field of research like computer science and cognitive mechatronics. I want to wrap up our module. Really, this is an iconic image that I think every one of us have probably seen at some stage. You're looking back to, I suppose, the massive stages of construction in the US, and it's an iconic photograph that was taken. I possibly think it might be late 50s, early 60s. I can't give an exact date, but I can tell you that this version of it is from 2019. And I picked it up, I liked it, from this paper by Barrettini and et al. And it's called Human-Robot Interaction, Safety, Standardization and Benchmarking. So it's a very topical paper to what we've discussed in this module. But you can see, I know some of the robots. I know this is Pepper. Pepper is one of the humanoid robots, and you can see a lot of other forms of robots, particularly these bipedal mobile robots, and you'd recognize some of these objects from a lot of the media communication that is going on around robotics at the moment. So really, to wrap it up, the Internet of Skills for robots, or robotic things, we're talking about a major paradigm shift, and that's absolutely critical, where the coupling between humans and robots, that cognitive coupling, needs to be optimized for the benefit of mankind and the longevity of our planet. So that's really where we are today. That evolution involves robots will evolve from complete isolation, and I think that's certainly what has been highlighted throughout this module, is that they're released. These robotic systems, these Tele-Operation platforms, they're out of the labs, they're out of the cages, and you'll see some of the literature refer to them as interconnected, human-centric cyber-physical systems. So they're cyber-based, but they're also physically interacting with humans on a day-to-day basis. The paper points out here another paper, which is Robotics 4.0. Are we there yet? That's a paper, and it queries and addresses the next generation. They'll provide services at every segment of the human life, thus changing lives dramatically. And I'd like to repeat that really, as this whole suite of technologies advance and become integrated in under the Internet of Skills, that will provide services at every segment of our human life and will ultimately change our lives dramatically, and most positively, that will be for good, dramatic change for the good of individuals. One of the things I'd like to wrap up is that there is so much going on at the moment and so much development in all of these fields as we move towards Industry 5.0 and the Internet of Skills. This is more a personal opinion and doesn't represent any organisation, but I question, are governments really ready? I know there's a lot of discussion and everything about the AI, but AI is just one component of what's going to be transformed when we are looking at the Internet of Skills powered by robotic things. So I think that's really where the work has to start. And it shouldn't be a situation of catch-up when all of this happens over the next decade. It should most certainly be an action on each government on a global scale to start addressing this whole transformation. It's like the Industrial Revolution that is going to happen as a result of the Internet of Skills. So there's just a number of references. I've selected them. They're reasonably within the last few years. So any one of these references, if you go to each one of these papers, you will find a whole set of further references that you could dig into if you want to learn more about the Internet of Robotic Things, robotic teleoperation, and the Internet of Skills. So there's a few references there for you to follow up on as required for your interest in this whole area of the Internet of Skills. And that's it. So we come to the end of our module on Internet of Skills in the context of robotic teleoperations. In conclusion, I would like to acknowledge the sterling work of our partners, and that is Analog Devices, and particularly Dara O'Sullivan, Nihal Amer, and Kate O'Riordan. Our second partner, Imdalo Technologies, I'd like to acknowledge Dara McNamara, Ivan Griffin, and Alan Dunn. Finally, in Tyndall, this work, and indeed all the support that I've received from my colleagues, Michael Walsh, Geronimo Javier Torres Sanchez, Masu Deman, Owen Martin Craven Grace. This is Alphonsus Alfikiri. Thank you for viewing our modules, and I hope that you've got a few ideas and concepts that will inspire you as we work towards the future Internet of Skills. Thank you very much for watching, and I do appreciate your time, and thank you again.